So we shall discuss section 3, advanced paper 1, section 3, question number 9. So the question is, two cylinders both fitted with a frictionless piston are fitted with mixtures of helium and argon gases. So we have basically two cylinders are there. Okay, so these two cylinders, so this is cylinder 1, okay, you have cylinder 2, okay, cylinder 2. So it is fitted with a frictionless piston, okay, you have a piston here. In both the cases, the gases are same, that is helium and argon gases. Okay, here also it will be helium and argon. Both of them are there in cylinder 2. This is cylinder 2. Okay, now the question is, in the first cylinder, the mass of helium and argon are M1 and M2. Okay, let me write this. So you have helium and argon, given mass. Okay, so in the first cylinder, given masses of helium will be M1 and M2. Okay, helium and argon will be M1 and M2. Okay, M1 and M2 respectively. In the second cylinder, the masses of helium and argon are M2 and M1. It will be exactly opposite. Therefore, helium and argon, the given mass will be M2 and M1 respectively. That's what is given. Then, the molar masses of argon will be 10 times of molar mass of helium. So, molar mass of argon will be 10 times. If I consider molar mass of helium as Me, then molar mass of argon will be 10 times of molar mass of helium. Okay, so even if you substitute the actual values, the molar mass of helium will be 4 and that of argon will be 40, you are going to get it. So same thing will be valid for here also, it will be 4 and 40. 4 and 40, okay. 10 times of molar mass of helium. The external pressure applied by the piston on the first cylinder, that means the pressure applied on the first cylinder will be 5 times of pressure applied on the second cylinder. So this is what is given. Pressure applied on the first cylinder will be 5 times that of the second cylinder, so that the volume of the gaseous mixture in both the cylinders are equal at the same temperature. That means V and T are constants here. V and T are constants. V and T are constants. If that is the case, then find out the ratio, that is M1 by M2. This is what the question. Okay. So now what we can do is, anyway, V and T are same. What are the variables here? The variables is M and pressure. So let us find out the total moles here. Okay, so total moles in the first cylinder will be equal to N1, I'll take it. So number of moles will be equal to, total moles will be equal to moles of helium and moles of argon. Okay, moles of helium and moles of argon. So moles of helium will be N1 is equal to given mass by molar mass, that is M1 by 4 plus M2 divided by 40. Okay, when you simplify this, you get N1 is equal to 10 M1 plus M2 divided by 40. Therefore, I'll write it here. When you write it in this way, so we will get it as for question 9. So N1 moles in the first cylinder will be 10 M1 plus M2. Okay. So similarly, the pressure P1 will be equal to 5 times of P2. Okay, I'll write it here. Then let us find out the total moles here. Okay, N2. So N2 will be moles of helium plus moles of argon. Okay, so moles of helium will be equal to M2 here. So M2 by 4 plus M1 by 40. Therefore, what are we going to get it? So we are going to get it as 10 M2 plus M1 divided by 40. Okay, so therefore I'll write it here. N2 will be equal to 10 M2 plus M1. Anyway, the pressure P2 will be P2 as it is. No change in this. So from this, we need to find out the ratio of M1 and M2. And they've given that each gas is behaving ideally. Whenever two gases are behaving ideally, we can apply what? PV is equal to nRT. Okay. So in this, what are the variables here? So P and N are the variable. Therefore, when you write two equations and divide, we will be getting it as P1 by P2 is equal to N1 by N2. Okay. Therefore, P1 will be equal to 5 times of P2 divided by P2 is equal to N1. What is N1? So this will be divided by 40 anyway. So this is also divided by 40. Therefore, number of moles N1 will be equal to 10 M1 plus M2 divided by 40. So whole thing divided by 10 M2 plus M1 divided by 40. So 40 and 40 gets cancelled, P2 and P2 gets cancelled. Therefore, we are going to get it as 5 is equal to, so 10 M1 plus M2 divided by 10 M2 plus M1. Right. So let us cross multiply this. 50 M2 plus 5 M1 is equal to 10 M1 plus M2. Therefore, when we subtract this, we will be getting it as 49 M2 is equal to 5 M1. Okay. Therefore, we are going to get it as M1 by M2, right? So M1 by M2 will be equal to 49 by 5. 49 by 5 will be equal to 9.8. Therefore, it's a numerical value question where the answer will be 9.8. Thank you.
The question says the total number of all possible isomers for the square planar complex with the formula K M NCS NO2 glycinato. Here, given the complex M NCS NO2 and gly. Here in this complex, here we have NCS and NO2, two ambidentate ligands are given, and this is unsymmetrical bidentate ligand. These two are ambidentate ligands. This is bidentate. Unsymmetrical ligand. So they are asking, this is having the coordination number 4. So having the square planar. So when you take the combinations M NCS and M NO2 will going to come by changing this ambidentate ligand M SCN and M NO2, and by changing these two M NCS and M ONO and M SCN and M ONO. So these combinations will be possible, and each case we can able to draw the geometrical isomers like glycinator. If we take with respect to N and O combination as it is a glycinator, so if you can take NO2 and NCS, same NO2 NCS, if you can change these combinations like this, each case 2 will going to get, there are 4 possibilities are there, so 4 into 2, total 8 isomers will be possible. So the total answer will be 8 in this case. Thank you.
Hello students, we are going to discuss the paper work question number 11. The question is the sum of the total number of carbonyl groups present in the major product X and Y in the following reaction. There is a compound which is C double bond O. There are 2 carboxylic acids. There are 2 carboxylic acids. These 2 carboxylic acids on heating, these 2 carboxylic acids on heating, these with respect to COOH group, if you consider this one alpha beta keto carboxylic acid, this is also alpha beta. So both COOH groups are beta keto carboxylic acids. Therefore, whenever the beta keto carboxylic acid is there, on heating it undergoes simple decarboxylation. So therefore, these COOH groups are left as in the form of CO2. So the compound is this one, and this compound has only one carbonyl group. There is only one carbonyl group. So there is another compound which is C double bond O, C double bond OH. There is another carboxylic acid OH. If you observe these carboxylic acid groups, with respect to COOH, this is alpha carbon, beta carbon, gamma carbon. Similarly, with respect to this one, alpha, beta, gamma. So whenever the keto group is present at the gamma position, that time instead of undergoing decarboxylation, the compound will undergo dehydration. So if you observe this, on heating this compound, instead of decarboxylation, it undergoes dehydration. That means loss of water molecule happened. So how the loss of water molecule happened? If you consider the cyclopentane ring, double bond O, C double bond O, OH, C double bond O, OH. From these two OH groups, one water molecule is left like this manner, and you will get the compound C double bond O, N hydride is formed. This is the N hydride. A ring is formed, 5-membered ring is formed. Here one C double bond O group, one C double bond O, here one C double bond O. In this compound Y, there are 3 carbonyl groups are there. So here 3 C double bond O groups, and in this compound there is one C double bond O group. So that totally 4 C sub double bond O groups are present in the X and Y compound.
Question number 12 I am discussing. The question is treatment of buta 1,3 diene with 2 equivalent of sodamide followed by reaction with excess of trans given structure gives X as the major product. The maximum number of carbon atoms that are collinear in X structure is. So we will first complete the reaction. Question number 12. Treatment of butadiene. How do we write butadiene? It is CH triple bond C. C triple bond CH. It is reacted with 2 equivalent of NaNH2. The concept here is acid-base reaction. This is base, this is acid. So there are 2 equivalent of NaNH2 and the structure is acidic with 2 hydrogen atoms. So I can remove 2 moles of NH3 which gives C triple bond C, C triple bond C minus minus. So this is anion, carbonate. The structure reacts with excess of CH3, CH double bond, CH2Br. So this will be connected with this as well as this anion reacts with another carbon atom. The structure will be C triple bond C triple bond C, CH2, CH double bond, CH3, and this side also I will get the same structure, CH2, say chain, double bond, CH, CH3. This is our final compound X. The number of, not carbon atoms, the question is number of carbon atoms which are linear, collinear. So we have to identify sp carbon. This is 1, 2, 3, 4. This sp carbon is influencing this carbon. Here also my count is total 6 carbon atoms are collinear.